Hi, today we're going to be talking about router on a stick, which is basically InterVLAN routing. And before we get started, I just want to assume that everybody knows how to configure VLANs and VTP because we're going to be making mention of that. Now, InterVLAN routing is a process used to allow VLANs to intercommunicate with each other. And at this particular time, we need a layer 3 device or a router to make that happen. So we're going to be going through some configurations of how to configure this particular router. We're calling it ROAS, router on a stick, how it needs to be configured to allow InterVLAN routing. If we look at our topology we have on the board, we have two switches, S1 and S2, and they are connected with dual .1 queue trunks so that we can extend VLAN information from one switch to the other. And just for simplicity, I've used different colors to show you the different VLANs we have. We all know that VLAN 1 is the native VLAN, which is used for management purposes. And we're assigning the IP address of 192.168.1.0 to that particular VLAN. And the switches themselves are assigned an interface VLAN 1, the 1.2 address, and the 1.3 address for S2 within the same network. VLAN 10 is going to be our marketing VLAN with that address. And notice that we're changing that third octet to 10.0 to show that it's on a different network. And then down here we have VLAN 20, the administration VLAN, which is on the 20.0 network. And I'm using colors to show you also that these hosts, the green host obviously belongs to VLAN 10, the blue host belongs to VLAN 20 on both switches. And the trunk, of course, is used to extend communication from switch 1 to switch 2. However, without having InterVLAN routing configured on this particular router, these two VLANs cannot communicate with each other. In other words, if I have this particular host, which would be given an IP address, let's say, of 10.2, and this guy would be given an IP address of 10.3, they can communicate with each other switch to switch because they're on the same VLAN. However, the blue host, which is on VLAN 20, would be given the IP address as an example of 20.3, and this would be given, let's say, 20.4. The blues could also communicate with each other because they're on the same VLAN. However, the hosts on VLAN 10 cannot communicate with hosts on VLAN 20, even if they're plugged into the same switch, without configuring router on a stick or InterVLAN routing. One of the key things to understand about InterVLAN routing is that if I wanted to trunk those two VLANs, in this case 10 and 20, I would require two different ports. I would have to have a trunk from each VLAN going up to that router, which would mean that I would need to have two router ports and then two switch ports available. And that's not a very scalable solution because if we had multiple VLANs, like 100 VLANs, I would need to have 100 ports on the switch available, and obviously 100 ports on the router, which can be quite costly and definitely not scalable. So router on the stick is an approach where we could use a single trunk. We create a .1 queue trunk, which is 802.1 queue, which is an IEEE standard for trunking today, where we can combine multiple VLAN traffic and send it across that one trunk. And for us to do that, we can take a single physical interface on the router, for example, Fast Ethernet 00, and create what we call subinterfaces. And a subinterface is nothing more than a virtual interface, and you can create countless subinterfaces on a router that they're virtual, but they actually can act like real physical interfaces and be given IP addresses, and they can participate in routing and whatnot. So for us, what we have to do, we have to create a subinterface for each VLAN that we want to route traffic for. Notice we have 3 VLANs. So let me show you how that is done. So what we'd actually do, we go to the physical interface. So let's say that this was the router, ROAS, and we want to go into global configuration mode. Of course, now we're going to go to interface Fast Ethernet 00, and the prompt would now change to config-if for interface configuration mode. And then I want to put no IP address on it because I will configure subinterfaces. And next what we'll do, we're going to start creating our subinterfaces. And to do that, we type the command interface Fast Ethernet, let me just erase that, 0/0.1. That will create the first subinterface that we're going to use for VLAN 1. And then we have to tell that router how to trunk as we talked about, .1Q. And so in the same interface configuration mode, what we'll now type is encapsulation. We have to type the word encapsulation. We have to encapsulate for .1Q. So we type encapsulation .1Q, and we have to follow with a space and the VLAN number that we're creating that subinterface and IP address for. And then the last thing we're going to do for that particular subinterface is that we're going to go ahead and type in an IP address of this router interface, the first subinterface that will be on the same network as VLAN 1, which is 192.168.1.0. And normally we would use the first IP address, 192.168.1.1, with a subnet mask of 255.255.255.0. So that would be the first configuration for that subinterface. And of course we have to go now and type no shutdown on that interface to bring it up and to make it active. And we will repeat those same configurations for the other two VLANs. We would go interface fast Ethernet 00.10 for VLAN 10. We would type encapsulation .1Q10 for that particular VLAN, given an IP address of 192.168.10.1 because it's on a different network at that particular time. Type no shutdown and repeat the same exact steps for VLAN 20. And what we have done now, we've created 3 different subinterfaces now. On that one physical interface, we will have subinterface 0.1, 0.10 for VLAN 10, and 0.20 for VLAN 20. So there's 3 different subinterfaces, 1 per VLAN, that will now allow InterVLAN routing. So now when this computer sends a ping to that computer on this switch or on that switch in different VLANs, now traffic will now go up on this interface and come back down. The router will say, okay, it belongs to a different VLAN, and route that traffic back to the switch, which will now forward it to the right computer. And it's called router on a stick because the router sits like on a stick on a single trunk line. Okay? And that's router on a stick in a nutshell.